Welcome to the Real Python Podcast. This is episode 86. Do you remember the one laptop per child program? What went wrong? And what can we learn from the program's failure? What are the potential pitfalls of charismatic technology, and how can we avoid them when introducing students to programming? This week on the show, former guest Al Sweigart and author Morgan Ames are here to talk about her book, The Charisma Machine: The Life, Death, and Legacy of One Laptop Per Child. We discuss the OLPC program and how idealized versions of our programming backgrounds can become traps. Morgan explains how these utopian visions are still used to attempt to disrupt education. Along with this cautionary tale, we also talk about educational programs that are working and how the entry points to programming are changing. This episode is brought to you by CData software, the easiest way to connect Python with data. SQL access to more than 250 cloud applications and data sources. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Well, I want to welcome back Al Sweigart to the show again.
Hello.
Hey, you had this idea that you had sent to me a few weeks ago and about this book that you had read, The Charisma Machine: The Life, Death, and Legacy of One Laptop Per Child, written by Morgan Ames. And I reached out and was able to get Morgan to come on the show. So welcome to the show, Morgan.
I'm so happy to be here. Thank you for having me.
Cool. So we initially wanted to talk about the book a little bit in the sense that kind of how this relates to learning programming and kids getting introduced to programming, but not only that, like adults getting introduced to it also. But I thought maybe I could ask you a little bit about your background, which I found kind of interesting as to it leading into your research and your own personal background with computing. So I was looking on your site and you have a BA in computer science and an MS in information science, and then a PhD in communication with a minor in anthropology, which I can kind of see how that kind of all connects to the types of research projects that you do.
Yes. Yeah. It kind of runs the gamut too.
Yeah. Which is really kind of cool. Just quickly, like what are some of the differences between computer science and information science?
Yeah. Very happy to talk about that. Information science is my current home department or home school, I guess, as well. Information science, most of the information science departments or divisions or schools around grew out of library science. They grew out of cataloging, training librarians basically, and kind of cataloging information that is stored in books. But in the 90s and early 2000s, a lot of library schools pivoted to include digital information. And of course, this makes them overlap some with computer science, with other disciplines that focus on digital information. But I would say information schools are much more applied, much more grounded in kind of real world applications and real world implications. That's really where we dwell and where we find a lot of meaning, where we put a lot of importance. And some faculty in computer science departments might also be kind of applied and focus on those kinds of things. But in general, and certainly my own training kind of pointed towards this, computer science often almost prides itself on being kind of separated from the real world, on being kind of abstracted, on being, being something that is more theoretical perhaps. And again, individual subdisciplines within computer science and individual faculty members might take different approaches. But I would say as a field, computer science is a bit more abstract, a bit more theoretical, a bit more focused on kind of the ins and outs of maybe programming languages or maybe, the limits of computation, computability, these kinds of questions rather than what effects do these systems have in the world.
Yeah, definitely. I can see that. Yeah, it's funny that sort of shift happened I think while I was in school, in like high school, the idea of like a library being turned into like a media center or whatever they wanted to retitle things, and the idea that like a lot of the computers that are in some schools at the time were sort of in those places, in the media center or in the library.
That was a big thing in the 90s too, with my experience, was getting computers in the classroom, and this idea that if we just dropped a computer in every classroom, this would somehow improve education in some vague and ambiguous way.
Yeah. Well, in the 1980s, in fact, when I was an elementary school student, which ages me, but that's fine.
So you're in a good group.
Yeah. I used one of the precursors to the One Laptop Per Child project logo. It was rolled out nationwide, including my completely ordinary, somewhat underfunded public school in suburban Salt Lake City, Utah. And so we had our weekly session on the logo computers in the back room of the library. So yes, I'm very familiar with that trend generally, as well as, the kinds of, I guess, computing imaginaries that even my elementary school held for us.
Yeah, we had, I think an Apple II lab in my junior high was like the first place that I saw that. This was in a suburb of Denver. And when I moved back to Arizona in high school, it was actually a much smaller computer area that they had. It was, I think, a set of like maybe TRS-80s or something. So again, aging myself.
So I think we all have that background of, we got into programming as children, and that's the main thing that struck me about the Charisma Machine, this book, was I saw so much of my own childhood in this under a much more critical lens, because I learned how to code in BASIC when I was a kid, and then later moved on to other languages such as Python. And when I first heard about the One Laptop Per Child project, I immediately thought, this is a great idea, because this will be just like programming was for me, and lots of kids will learn computing and how to code, and even if they don't become software engineers, they'll become more capable adults, and all you just need to do is put computers into kids' hands.
Right, the magic ingredient.
Because that was sort of what my experience was, learning to code in BASIC.
Absolutely, yeah. I'm so glad that you highlight that, because I think many who joined this project, certainly, who were employees of One Laptop Per Child back in the day, but many who contributed to it in other ways. Maybe writing open source code, maybe, buying one or more give one, get one laptops, maybe discussing it online. They really saw themselves reflected in these stories too. And it was, in fact, for at least my contacts within One Laptop Per Child, it was very common to kind of talk about, well, when I was a kid, I used this kind of machine. This is the sorts of things I did on it. This is what I want to unlock. So it was a very conscious part of the design process from again, what I heard, and then what I gleaned from all of these very extensive online discussions about the design process.
We should probably go into what the OLPC project actually was, just for people who aren't familiar with it, because it was 10 years ago, 15 years ago.
Yeah, 15, 16, I think it was first announced now. So it's been quite a while. Yeah, it's funny. I talk to undergrads about it in particular, and I get lots of blank looks, so I have to go into a little bit of detail about it. So yeah, it's a project that came out of the MIT Media Lab, sort of spearheaded by Nicholas Negroponte, but really with Seymour Papert as the kind of intellectual leader for it, both professors at the Media Lab. And its goal was to put a low-cost, easily repairable, open source software computer with a lot of educational software on it in the hands of every child across the global South. And the idea, much as you articulated, was that once they had this laptop, they would be inspired to explore it, to learn programming languages, to connect with other children, to really leapfrog past the adults in their lives to, make up for any kinds of infrastructural deficiencies. The idea was that this would have a mesh network. It would allow kids to connect to one another even across the town. They could share internet connections as long as somebody had one. There was a view source button, so they could hit that button and see the source code of whatever program was running. They could charge it in a lot of different ways. Originally, Nicholas Negroponte was talking up the fact that it would have a hand crank to charge it.
Yeah, I always thought that was fascinating.
Oh, wow.
Yeah, this was not feasible, sadly, for a number of different reasons. You couldn't generate enough electricity. It's not great for hands, honestly.
Yeah. I bought one of those emergency flashlights with the hand crank, and what you immediately realize is that you really can't generate enough electricity, and also your hand will cramp far before you actually recharge the battery on that thing. It's just not
absolutely.
It's not practical.
Yeah, and if you need to crank that much for just that one little LED, or maybe they have a few little LEDs in there, this was a lower power computer, but it still needed power. So anyway, that was the idea, right? And it sounds like a great idea. Honestly, one of my motivations for going into computer science myself was to make the world a better place. And so I really understood why people were so attracted to this, because here is this project in very concrete terms trying to make the world a better place, and in a way that really resonated with computer scientists in particular. So there were a few, other pieces of this. They really wanted children to own the machines, and this was kind of a cornerstone of Seymour Papert's philosophy that goes back, again, developing this particular, really most popular branch of the Logo programming language, Turtle Graphics as a kind of part of that, other collaborations and projects that he had over the years. But one central part was that kids should really be free to explore things as deeply as they want. So kids own the laptops. They were targeting elementary age kids. This isn't a high school project. It's elementary school. They wanted these to be connected to the internet. This was, not a requirement. Different projects on the ground would have to kind of work on those logistics themselves, but that was kind of the idea. And they wanted all kids in an area to have them. And then again, as I mentioned, they were committed, with only a few little hiccups along the way, to free and open source software. And that is what the laptop shipped with. It's a Sugar, which is a kind of windowing system on top of, I believe, Fedora Linux. And then there were a number of applications that had been developed over the years by either MIT Media Lab or other affiliates, such as Scratch, the Tam Music Suite, Turtle Art. I think it was renamed Turtle Blocks and then back to Turtle Art, eToys, Alan Kay's project, and other things that have been developed over the years, shipped on this machine.
Yeah, it's interesting that you bring up Turtles, because I'm using the Scratch programming environment, which is also from MIT, and it's headed up by Mitch Resnick, who I believe was a grad student of Seymour Papert. About a year ago, I think they released Scratch version 3. And one thing that I noticed is that the pen tools, which were basically the Turtle tools that would let you draw lines and spirograph art and sort of things, they now have those hidden by default. You can still add them in, but they're not a part of the code blocks that you can use normally. And so from what I gather is that the Turtle graphics features of Scratch just really aren't that popular with kids who are using it.
Yeah, I think back even in the 1980s, I remember as an elementary school student, a lot of it was over my head at the time, I got to say.
Yeah.
And I didn't have that kind of open-ended opportunity to explore at the time. But I think it was a novelty in the 1980s when displays were, still often just 4 colors, right? Or maybe even just one color.
Oh, yeah.
The fact that you could move things around on a computer screen was like, whoa, really? And of course, now kids have touch screens, right? They are very used to cursors. They are very used to the idea of interactivity. They are very used to a really rich multimedia environment. So I think in many ways, things like moving a turtle across the screen just aren't necessarily as compelling. In fact,
Right.
A lot of the things that many of the OLPC people remember from their childhoods and the way they, in a way, kind of mythologize their childhoods, and I'll talk a little bit more about that in a minute,
Yes.
are not necessarily true for today's kids. It's a very different, media landscape. It's a very different kind of programming, computing environments.
Yeah, text-based games aren't really they don't have the same hold on kids anymore.
Yeah, exactly. And so many, I mean, there are so many games, of course, that use in some ways the same mechanics as a text-based game, right? There's an adventure game, but there's an expectation of these rich graphics that accompany it. So yeah, I think it's changed a lot. So I'm not surprised in a way that Scratch and that Mitch and his team made that decision. I think in many ways, even though Scratch and Mitch's projects more generally are very much kind of in their tradition of Seymour Papert's philosophy. In fact, Mitch Resnick holds the Seymour Papert endowed chair at the MIT Media Lab. He and his group have really done their best to learn from the mistakes of One Laptop Per Child, of Logo, of other things, and really try to make a bit more inclusive environment. That said, I think they still, tend to have a fair number more boys than girls in the Scratch environment. Some of the most active members are girls, interestingly, but there's still some kind of cultural baggage around who gets to program, who is seen as quote unquote a natural, that influences things like Scratch. And even with the changes, one thing I do like about Scratch is that they tend to focus a little bit more on storytelling and kind of theatrical aspects, right? You move this cat around, you tell stories with the cat. There's a kind of natural theatricality to Scratch, I would say.
Right. It's not just calculating Fibonacci sequence numbers.
Yeah. Or making pretty pictures, I think, is a wonderful motivation for some in Logo, but it really doesn't grab some people. Whereas telling stories also doesn't grab some kids. But I think we tend to think in stories. We tend to make sense of our lives and our surroundings in stories. And so that, I think, lends itself a little more naturally to that being a good entry point into programming.
CData software. Connect, integrate, and automate your data from Python or any other application or tool. At CData, we simplify connectivity between all of the applications and data sources that power business, making it easier to unlock the value of data. Our SQL-based connectors streamline data access, making it easy to access real-time data from on-premise or cloud databases, SaaS, APIs, NoSQL, and big data. Check out cdata.com to learn more. I have a question about, you mentioned that one of the ideas behind the direction of where they were going to implement this project of One Laptop Per Child was the Global South. And I guess I haven't heard that defined. Is that South America and other, like Mexico, or what are the different places that were included in that?
Yeah, I think that many people would say, quote unquote, the developing world. Okay. What we used to say, the third world, right? The third world was a kind of Cold War legacy. The first world being the democratic nations, second world being communist, third world being the places where those two were jockeying for position. That was kind of replaced by the developing world, but there's so much baggage around development and the politics of development, who developed for whom, by whom, right? Who sets the bar for what is developed, et cetera, that anthropology and other fields tended to move away from that and say the Global South instead. And of course, this has its own politics. Anything any term we use for this kind of thing will have its own politics. But the idea is, in a way, talking about, quote unquote, the developing world without those connotations of, well, here's what's developed and here's what's not developed and here's the path you take to development. It really takes into account all of the, or tries to at least, takes into account all of the, legacies of extractivism that have shaped many places across the Global South, certainly the countries in Africa, especially Central Africa, but also, Latin America, South and Central America, the Caribbean, the Pacific Islands, South Asia. There's a lot of different places that would be counted as, quote unquote, the Global South. And that term just nods to that history a little bit more. Okay.
One of the big focuses that you have from the title of the book is this idea of charisma. And I kind of want to get your interpretation of that and kind of like how these sort of charismatic models have developed over time and are sort of held up, if you will, a bit of on a pedestal of like, this is how it's done.
Yeah, sure. So, well, when we think about charisma, right, in a kind of colloquial sense, we often think about people. Oh, there's a charismatic, I don't know, a cult leader maybe, or a religious figure. Certain politicians are charismatic, right? They have a kind of magnetism. They attract attention. They draw people to them and to their cause. And one move that my what I would say is one of my core disciplines, science and technology studies, is to use some of the same analytical tools that we use for people on objects and to think carefully about what that might serve. One of the reasons for this is that science and technology studies, STS, acknowledges that objects like laptops, like maybe infrastructures, other things, end up having effects in the world beyond what the designers intended, right? It's not just a kind of conduit for whatever the designer wants, right? There's this kind of back and forth between a technology and a user. Of course, the design of the technology initially is also something that doesn't happen in a cultural vacuum. There's a kind of back and forth between what the designer thinks the world needs or a particular user base needs, how they understand the world, how they understand those technology users, and then how they kind of instantiate that in design. So when I thought about this, as I was following the One Laptop Per Child project, I kept coming up against these ideas that seem to have a kind of life of their own in the world. And certainly Nicholas Negroponte as a kind of spokesperson for One Laptop Per Child, and others who were part of the One Laptop Per Child project were promoting certain ideas. But the laptop itself came to symbolize a kind of future, a kind of utopia that in some ways took on a bit of a life of its own. And so I thought, this laptop itself kind of has charisma. It symbolizes this particular worldview and this particular hope, this particular utopian hope that maybe takes slightly different shapes among different communities, but still is kind of charismatic in how it resonates with them. So yeah, the idea of charisma ends up tying in kind of closely with this utopianism in the case of One Laptop Per Child.
Yeah.
Now, utopianism, as a kind of literary idea, often is about a construct of a world that is very separated from our own. But within technology, utopian ideas are very common.
Yeah, this idea that we can solve racism by creating an app.
Right.
Yeah, exactly. And it sounds, when we put it in such stark terms, it's like, okay, that's probably ridiculous. But various forms of these stories circulate. They get kind of co-opted into different projects. In some cases, really the same story. So what I found interesting with the One Laptop Per Child project, this laptop was charismatic in a way that really resonated with existing worldviews of the open source community among those who consider themselves part of the quote unquote, hacker crowd of MIT. And these are hackers not in the breaking into computers sense, but in the, passionate technical tinkerers sense, which has a long history at MIT and elsewhere. And moreover, this wasn't the first time that these stories had been kind of embodied in a project and in a piece of hardware, right? The same stories were told about Logo. The same stories have been told about other pieces of children's technology. The same stories have been told since, too. So even though One Laptop Per Child in many ways failed, the same stories came up when we talked about MOOCs or maker spaces or, tech-heavy charter schools. There are a lot of different movements that promise the same kind of, inspirational tinkering to children that One Laptop Per Child promised without really taking into account why One Laptop Per Child or the previous iterations of it didn't succeed.
Yeah, and we see this continue today in other spaces in tech. A lot of hype around AI and deep learning or blockchain and cryptocurrencies or virtual reality and augmented reality. Those are things where it's like, hey, we can just add a VR headset and suddenly the metaverse is cool and practical and a good idea. When really
our meetings will be enjoyable.
Yeah, when really you just end up getting motion sickness and you have a sweaty set of goggles strapped to your face for 3 hours at a time. Yeah. We tend to see the great appeal of it and not the impracticalities of it.
Absolutely. Well, and I think virtual reality in particular is one that has certainly been in the news a lot the last little while.
Yep.
Ethan Zuckerman wrote just a wonderful essay. He is a former MIT Media Lab professor, but just really thoughtful about his own contributions from the 1990s onward in the realm of virtual reality and augmented reality, and why those ended up kind of failing. And I think they failed for many of the same reasons that you talk about. But more broadly, I would say that many of these utopian visions don't connect themselves to the messiness of real life. In a way, we rely on holding them at arm's length and saying, oh, here's this shiny, very different vision from our everyday life. And the role of utopia as a kind of escapist view is, of course, in literature, well established. But I think it tends to be a little under-examined in technology. The lack of connection between, our everyday sitting in front of our computers for Zoom meetings, whatever it might be, and that shiny vision of the, hyper-modernist Mark Zuckerberg room, or, playing cards with your friends online, or whatever it might be, right? There isn't really a connection with, well, what do I have to do kind of day to day in these spaces? How would that be different in virtual reality? How would it be better? How would it be worse? A lot of that gets shunted away in these utopian visions.
Do you feel like they don't have the wherewithal to do a longer study of that thing, as opposed to rushing to shove it out into the market, like actually have a group of people use it for a year or whatever and think about it? I think of the mission to Mars kind of things, how long can people stand being together, these kind of biosphere kind of experiments that happen with humans.
We kind of found that out the last year or two.
Yeah.
No, indeed. So I think, every project ends up being run a little bit differently. There have been many experiments with how these ideas, bear out on the ground in various iterations, certainly with VR, right? There are lots of people who have been studying this for decades. Similarly with, getting computers in the hands of kids. Lots of people have done one-to-one laptop projects. They have maybe, followed Seymour Papert's suggestions in really giving kids full access in some cases. Other ones, the laptop might be owned by the school or might be locked down in various ways. One troubling trend today is that these laptops from schools are often packed with surveillance software where teachers can kind of track and administrators can track remotely what kids are doing on the laptops.
And that's at school or even at home.
At home, including, yeah. And I would say this is a dystopian vision that is very close to reality, unfortunately. And it is reality in many cases. But more broadly, I think both of these visions, right, really rely on being separated from reality. When you account for what those teams are actually doing and exploring on the ground, the utopian vision ends up kind of falling apart because you realize, oh, there's a lot of kind of messiness that goes with this project. There are people who don't want to engage in this way. What's going to become of them? There are people who maybe co-opt it, maybe abuse this platform in various ways. What happens then, right? All of this gets shunted away in the utopian story. So in a way, even though people have been on the ground doing the kind of work that is needed to understand how this would actually fit in the messiness of day-to-day life, the utopian stories persist and they get retold again with a lot of similarity across a lot of new technologies.
And I think Python plays sort of a large role in a lot of this because right now and for the last several years, or really actually for the last several decades, learn to code has become this idea where if we just learn to code, then people can automatically improve their lives. And, I'm the author of Automate the Boring Stuff with Python, which is a book that's really sort of aimed at office workers and teaching office workers how to code or people who aren't necessarily software engineers. And one thing that I've noticed is that now there are a lot of self-published books that you can find that are trying to cash in on this trend. And when I look at Amazon, and I can always pick them out because they'll have the kind of amateurish cover design. Their titles will be about 30 words long because they're trying to capture all the search engine terms. And they'll have about a dozen 5-star reviews the week that they come out, and then no reviews after that.
Yeah.
So pretty clear that they're just buying reviews to promote them. And that's one reason why when I read The Charisma Machine, I thought this is such an important book, because this is going to keep happening over and over again, where technology makes all these promises and we get really caught up and mesmerized by the charisma of it all. And we don't ask the very practical questions of, does this actually work in the real world?
Absolutely. So I want to, one reason I'm so thrilled to be here on this podcast is that I actually love Python. It's my scripting language of choice. I definitely lean on it for, at this point, kind of spaghetti code scripts of, I need a bunch of articles from a website and I don't want to download them all manually, whatever it might be, right? I love having that skill set to lean on, and I think there is power in it. And as a kind of a code, I remember talking back when I first learned it in the early 2000s with some of the people contributing to the language design, which some of them were at Berkeley at the time when I was there as an undergrad. And one of the goals of Python, of course, was learnability. Make it really clear. Make it something that isn't, Perl at the time was also very popular. And of course, Perl is known for its obfuscation. People are proud of their very obfuscated Perl programs.
Yeah. You can mash the keyboard at random and produce a syntactically correct Perl program. It's very punctuation heavy.
Yeah, with regular expressions included.
Yeah, exactly. So Python was a wonderful alternative to that, and I think that as a learning platform, and even as a kind of core programming platform, it's really wonderful. That said, the movement to teach everyone to code is one I worry a little bit about. I do think there is value in it, and I think everyone just knowing a little bit more about how their machines work, what are the real limitations of them, right? How can you figure out what they're doing if you're maybe worried about, are they recording me? What's going on, right? Knowing a little bit about how your machine works means you can at least somewhat investigate some of those things and understand what's going on. That said, I personally feel like a missing component of many of the Learn to Code sorts of initiatives, the Hour of Code and other things, is a kind of critical awareness of how computing environments situate themselves within our lives more broadly. Certainly their role in surveillance is something that I am very worried about. And I mentioned earlier, surveillance even of school children is incredibly common today. Our data gets kind of harvested and repurposed. Of course, there's a lot of garbage in that. And one of the old maxims in computer science is garbage in, garbage out. So we may not actually get much value out of that. But of course, one thing that AI promises, whether it can deliver or not, is yet to be seen, is that it breaks that maxim, right? Garbage in, but you get enough garbage and you can start to glean insights. Now, the way that ads get targeted or mistargeted at me on a regular basis, I somewhat doubt that, but, I reserve judgment.
Sure.
I think that AI is good for certain things. I fear some of the things that it might be used for. Certainly, facial recognition everywhere we go is something that I think is actually really harmful, and a huge invasion of privacy and kind of self-determination. But there's, a lot of other wonderful things that come from it. Language translation has improved so much with these amazing language models, right? So I think there's good and bad in that. But more broadly, sorry, I tend to ramble a little bit. There's always so many great topics to cover.
Oh, yeah.
I would say that I really want kids who learn a little bit about coding to also learn a little bit about kind of critical perspectives on computing environments. Learn a little bit about those surveillance networks, learn a little bit about the kind of political economy that supports them, learn a little bit about how to tell truth from fiction, what kinds of incentives people have to tell lies online and what those lies might look like. How do you verify things, right? All of these kinds of critical media sensibilities are things that are traditionally taught in humanities, right? English classes really have focused on this, but certainly at the college level, those sides of campus have been consistently defunded for decades at this point. And it's, certainly at Berkeley, there's this whole new division of computing, data science, and society. They're heavy on the computing and data science, still working out the and society part. But are really focused on those technical skills and not necessarily the grounding in, okay, what are the consequences of this? How do we grapple with this in our daily lives? How do we make sense of it? How do we push back against it when we need to? And those are the sorts of things that I certainly try to teach in my own classes, kind of hand in hand with technical skills. And I would love to see incorporated more broadly into these Hour of Code and other kind of learn to code initiatives.
I think that's fascinating. I agree that the critical perspective is something that isn't focused upon, and maybe it's because it hasn't had its own sort of charismatic model for that in the background. I was thinking of a joke that I've heard a lot lately that the older generations were so worried about video games, messing with kids and distorting their views and making them all,
don't sit so close to the TV.
Right. And meanwhile, this older generation has completely been filled with misinformation from Facebook and what have you,
Yeah.
Television too. Yep.
Be careful of strangers on the internet. And now we get into strangers' cars that we've summoned through the internet.
Oh yeah, totally. Yeah. Well, I wonder if in that idea of I would find it fascinating, but again, I'm what you had labeled as a precocious boy, technically precocious boy. And so I'm interested in the idea of what information is being gathered about me, what information, and actually finding the ways around that. And I wonder though, as kids generally are sort of swimming in technology today, what is the step that makes them, take a step back and say, hey, what is happening here? And, and kind of gathering that information.
Yeah, it's a big question. There are a couple pieces too that I'd love to respond to of your comment.
Yeah.
One is that media scares, right? Oh, video games are terrible. We hear it now about phones, right? When usually in middle school, that's typically when kids start to get phones. Sometimes it's a little younger, sometimes a little older. But when they get those, there's a whole kind of
screen time and all that stuff.
Yeah, all the scares. And that comes back all the way to preschool, right? All the talk about, it's like drugs for your child's brains, right? Same story we heard about video games, same story we heard about television, same story that was told about novels back when novels were kind of new and kids were not reading the Bible, they were reading novels, right? And it's going to rot their brains. So I love kind of just historicizing that a little bit and saying we've told those same stories over and over. In a lot of ways, those dystopian stories can be flip sides of utopian. Both of them are removed from reality. And I think you're really insightful and on point in saying that, this kind of critical digital sensibility doesn't have a charismatic story. You are absolutely right. I mean, I feel like this is, a common problem with a lot of movements that end up really grounded in people's lived experiences. It can be hard to distill that really messy reality with a lot of different competing desires into a crystalline and really compelling image, into that charismatic story. I think that we should have more movements that do try to do that try to galvanize people around maybe labor conditions. I do feel like there's been some shifts within the technology industry in the last few years towards, unionization, towards attention to labor, towards attention to what kinds of precarious labor platforms like maybe Amazon Mechanical Turk enable, right? And what that means for kind of the economy more generally. So I feel like there's some stories around that in particular, but there aren't a lot of really compelling stories around kids using tech. It's not a drug for their brain. Anything's fine in moderation. The flip side of that, of course, is kind of connects to, as you mentioned, the technically precocious boy idea. And this is the idea that kids take to technology like fish to water, right? They're naturals. They're so good at it. They pick it up so easily. I've certainly worked with a lot of children, and many of them are really fearless when it comes to technology.
Yeah.
I do think there's a worrying elision, though, between that fearlessness and real technical knowledge. Certainly, there are a lot of students who come to college, for example, having kind of learned a little bit about code and written some programs, and they have a lot of confidence, but they don't have a lot of good technique, right? It's like somebody kind of tinkering around on a musical instrument and being like, "Oh, yeah, I'm really great," right? Without being able to listen to others playing that instrument or to really have any kind of music technique behind it. This isn't a perfect analogy, but
right.
But that idea of the self-taught coder.
I mean, one thing that I tell people over and over again is that I was one of these kids who quote unquote taught themselves how to code, but really everything I learned about programming between the third grade and graduating high school, you could probably teach yourself in about a dozen weekends or so. Like it turns out, like my head start wasn't really that big of a head start, and I didn't know nearly as much as I thought I did.
Yes, yeah. I had lots of friends. So I was not a coder in high school. I came to it in college, but I had lots of friends who considered themselves very good hackers in high school.
Oh, yes.
And as I got into computer science, I was like, "Oh, is that all? That's what they were talking about? Oh my gosh!"
It's like really they only knew that one weird trick. Yes,
exactly. Yeah, they were a headline ahead of their time. The one weird trick.
This week, I want to shine a spotlight on another Real Python video course. It uses a real-world project to help you hone your skills with wrangling data using Python. The course is based on a step-by-step Real Python tutorial by Brian Weber. And in the course, instructor Cesar Aguilar takes you through how to load and merge data from multiple sources with pandas, how to filter and group data in pandas data frames, and how to calculate and plot grades in a pandas data frame. Along the way, you'll practice many of the skills you need to work effectively in pandas, like working with CSV files, aggregating values, and how to assemble it all into a real-world project. Like all the video courses on Real Python, it's broken into easily consumable sections, plus you get additional resources and code examples for the techniques shown. All of our course lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com.
So I want to get into that story a little bit, though, about the technically precocious boy, because I think the way we tell stories to ourselves and to others about our past is incredibly, incredibly important for how we see ourselves, how we act in the world. And in the tech world, that story of teaching yourself to program, right? Of falling in love with the machine, of really it being about you and the computer, has a couple downsides. One is that it tends to exclude people like me who came to it in college, right? I really liked math before that, but it wasn't until college I took my first programming class. It tends to exclude others who find other routes, right, that don't have that kind of neat and tidy mythology that you're able to kind of fit into that. Here's how I taught myself to code when I was fairly young. It also obscures all of the things that helped you along the way. And of course, I don't know your story in particular, but in many cases, right, there's somebody who got that person, that child, a computer in the first place. There's someone who maybe gave them access to maybe it's coding magazines, especially in the 1980s, right? The back of Scientific American had basic programs you could type in and then run and then debug and figure out why it wasn't working the way it should. There were many magazines dedicated to this at the time. And that's how a lot of people learned to code. But somebody brought those into the house, right?
Right.
Somebody enabled that access. There was, and of course today it's more, maybe it's Stack Overflow, whatever it might be. There are a lot of different tutorials online, these hour of code things. There are whole big teams, right? There's a whole kind of big Google team devoted to hour of code and other volunteers as well. And then this gets kind of deployed through teachers and parents and others who support those activities. And then, of course, there's somewhere these people go when they have trouble, right? If the computer's not booting properly, if they run into some bug in their code, maybe they look it up, but they have to figure out how to look it up. This really came to the forefront when I ran a summer camp with a colleague of mine, Jenna Burrell. We ran a Minecraft summer camp in Richmond, California. It's a low income, historically redlined community just north of Berkeley. And most of our kids were Black or Latine children. They were passionate about Minecraft. They had played it a lot on mobile devices, on tablets. But when they came to us, many of them hadn't used computers much. Installing Minecraft mods was really a technical process. You have to kind of go in and copy JavaScript files into a particular folder on your machine. That's not something that's going to be available to a lot of kids. So even the stories about Minecraft we tell of there's this great environment to kind of foster computational thinking. You can mod it in various ways, kids to learn to program in it. Only kids who have a really technical set of resources to draw on, whether it's a parent or a teacher or, I wouldn't want to claim our one-off, I guess it happened a few summers, but our summer camp for a few summers really influenced those children much, right? That's not a kind of ongoing resource they could draw on, but they got a sense of how different Minecraft maybe is and more flexible it is on a computer from us. But those stories tend to obscure all of those other resources that factor into people learning to program.
Yeah, it's funny, the Minecraft thing. I've done a survey kind of asking people about this, and where a lot of people ended up going from a Minecraft sort of background isn't necessarily into the programming part, but they learned all these skills that are really useful in sort of DevOps, like all the things that are required to keep the machine running, to have a server, to the care and feeding of all the packages and stuff that go into it and so forth. They kind of learn all that sort of interesting infrastructure stuff, which I thought was it's very different. And Al, you had a experience with your Minecraft book, right?
Yeah. And also just talking with kids and other folks who did that sort of Minecraft admin to IT sort of transition, because there's so many things that come up when you want to just have a Minecraft server for your friends, and then you learn about all the mods and all the versioning conflicts between mods and uptime, and then even setting up monitoring systems and community moderation. Just to prevent griefers from destroying everything in the virtual world.
Oh my goodness, yes.
And even to the point of some cybersecurity stuff where you want to prevent other people from sending a denial of service attack against your Minecraft server because they got mad at the admins or something like that. So it's sort of provided that a motivation really to get into IT and DevOps type roles. Yeah,
absolutely. There's so much that has to go into it. And I found that for a lot of our students, maybe many of them had kind of one broken down computer at home. Maybe it wasn't even functional, or maybe it was kind of barely functional, but it wasn't connected to the internet because people had only internet connections to their phones. But, they weren't allowed to tether, for example. So their computer was kind of an isolated thing. And they were typing, some of these, usually it was brothers or sisters of the people in the camp because they tended to be a little bit younger. But some of them were in high school or early college. They were literally typing up essays for their classes on their phones because that was their computing device.
Oh, wow.
Or they would go to the school to type things up on very overused computer labs, or they would go to Richmond Library, which was only open, in 4-hour chunks a couple days a week because they were so underfunded. Right? These are the kinds of computing environments that are so common across the United States and the world, but get elided away in visions of virtual reality or visions of, remote schooling.
I mean, it's kind of a pain to because we have such a huge e-waste problem, and I know I have desktop machines and even laptops that are half built just in the room that I'm sitting in right now. And, just because we have plentiful computers everywhere. The hardware's there. That doesn't mean that it's working, that it's operational, that people will have the tech support needed or the internet connectivity. Even if they have internet on their phones, like you said, that's not the same thing as having a desktop computer or a laptop computer with internet on it that they can use. And there's such a wide range of all these devices. And unfortunately, nobody can really make lots of money by recycling old PCs and putting in all the labor and effort into getting people's old computers up and running. It'd be much better just to have a $1 million deal to have a school district buy iPads and that sort of thing.
Yeah, and I got to say, the $1 million deal to buy iPads or $10 million, whatever it might be, right?
Yeah,
is a lot flashier, a lot more utopian than the ongoing care and maintenance of those iPads, and then the training that teachers need, the training that students and families might need. All of those pieces aren't the exciting parts of those projects. And this is a big problem, I think. Certainly a big problem in the One Laptop Per Child project. There was a lot of focus on getting the machines into the hands of kids. Seymour Papert, in a talk in 2016, literally said, or 2006, literally said, 8-year-olds can do 90% of tech support and 12-year-olds 100%, and it's not exploitation. It's a valuable learning opportunity. This was not true in the field, right?
It turns out 8-year-olds aren't just going to swim in technology so easily that they can repair microchips. Exactly,
yeah. And the sorts of things that went wrong with these machines, the most common breakage point were chargers. The cables they didn't choose well. They're these plastic cables that can stretch. Kids swing things. Man, if you've interacted with, I'm sure you've both interacted with kids and machines. Like, they fiddle with stuff. They break stuff all the time. They break cords, especially in the Minecraft camp Jenna and I ran. We had headphones for all the kids, and boy, those headphone cords just took a beating.
Yeah, I worked at a school for recording engineers, and it was like post high school, but it was a mix of things. And the guy was sort of the main technician to take care of all the equipment. He said, you can never make anything student proof. You can just make it student resistant. That was like his claim.
That is such a wonderful, in much the way that water resistant things, you don't actually want to get them wet.
Yeah, exactly. It's not the idea.
It's funny that you bring up how sort of, we got all these laptops into the hands of kids and then just sort of walked away because all of the other stuff isn't the fun part of the project. And I think a lot of programmers can relate to this because it's a lot of fun to write code. It's not a lot of fun to write documentation,
right,
or comments or unit tests, or promote your open source project on forums and social media and all these other things that are absolutely necessary for a working piece of software, but aren't as fun as writing the initial code.
Absolutely. Well, and you look at how, project software maintenance in particular goes out in the world too. I have a friend, Marissa Cohn, who did this wonderful study of kind of long-term NASA projects, right? A lot of these rovers that get sent or probes that get sent are launched, but then it's 10, 15, 20 years until they actually reach their destination, right? And all during that time, there is maintenance work that needs to be done on the project. She found that these maintenance teams were largely staffed by women. They were incredibly technical. They dealt with all kinds of just crazy, software faults and other things that had to be pushed to, some probe that's the light takes maybe half a day to get there, right? The message takes that long to come. And so it's a whole day before they get a message back knowing whether they succeeded. And these were not the sexy projects at NASA, right? There were a lot of kind of men jockeying for promotions who were on the launch team, and then the maintenance team ended up being more often these kind of long career women on the projects. Anyway, that's a...
And that goes back to the history of computing as well, where it was considered like hardware design was the cool part, and so that was men's jobs, whereas actually writing the software was seen as sort of clerical work, and so a lot of the first programmers were women.
Absolutely, yeah. I'm glad you bring that up. I love in some of my classes going over a little bit of that history of computer science, of programming, and talking a bit about how this was a woman's job up until the 1960s, really. And women were incredibly technical, incredibly, in many cases, pretty well paid, because if they left, the project would be kind of in dire straits, but were generally not kind of well regarded, because that was the culture of the time. As you said, it was seen a little bit as clerical work. And then, of course, there was this shift in the 1960s and 1970s that, many historians have traced in detail. Nathan Ensminger has wonderful histories on that. Fred Turner also talks a bit about how, ideas of computation ended up getting attached not to these huge government projects, which really defined computing in the 1950s and 1960s, often with defense ties, but ended up being connected to the counterculture of all things, right? And this idea of hackers being kind of countercultural was something that was really actively fostered in part by the very people who were behind One Laptop Per Child. Seymour Papert joined MIT in the 1960s, joined Marvin Minsky's lab. Minsky's lab, of course, is famous for enabling hackers, self-described hackers, to use all of the big timeshare PDP computers overnight. And they programmed Space War. They programmed all sorts of fun games. They played pranks on one another. This was part of the culture of MIT as well. But this really became a kind of source of a lot of both computational mythologies and also a source of this shift from programming being kind of women's clerical work to programming being this kind of macho thing to do, almost an alternative to the kind of, the jock sort of persona, that kind of archetype of, if we think, or stereotype perhaps.
Yeah.
So yeah, I would say that certainly programming is not something that has to be masculine. And one reason that I love telling that story to my students is because it really blows away some of their preconceptions about even some of the movements to bring more women into computing, right? There's a lot of movements around we just need to, make sure we get more women in the pipeline early and make sure they don't drop out and make sure and it's what have we done to change the cultural assumptions around computing? These are not natural in any way, right? They were something that were the product of especially a kind of late 1960s into the 1970s and also into the 1980s shift in computing cultures. And knowing that history can really be beneficial.
Yeah, I talk about that with my own history of learning how to program, because I was really into Nintendo, like the 8-bit Nintendo Entertainment System, and I looked into the history of just video games and how Atari Pong was really popular in the 70s, but then there were all sorts of other cheap knockoffs and really low quality games, and it culminated into the video game crash of 1983, where video games almost just stopped being a medium or a form of activity. It was, I think, 97% of the revenue for video games just fell out in that 1 year. And what really sort of saved video games in that period was Nintendo from Japan, where they took the time to develop well-designed games that were really accessible, but also changing in the way that they marketed it. In order to create Nintendo games, you had to be licensed from Nintendo so they could have quality control. And also, instead of selling these Ataris and other video game consoles in the electronics section of stores, they wanted to sell video games in the toy section of stores, and all toys were split into boy toys and girl toys. And so there was just a decision of, well, video games will just be sold in the boy toys section. And that has had a lot of repercussions to this day, where video games are seen as something that predominantly boys do. Like, most gamers are considered to be men, or even though when you actually look at the numbers for video games, it's pretty much split evenly across the population.
Yeah. Absolutely. I'm so glad you go over that history. And that decision to put the consoles and the games in the boy toy aisle fits a century of marketing technical toys to boys. If we think of erector sets, if we think of, kind of early, kind of engineering applications, right? There's always been this
little chemistry sets.
Yeah, exactly. There's long been a association with particular toys, of course, with play and with kind of freedom. This was something that, especially after World War II, there was this movement to have, the family den, quote unquote, full of kids' toys. Rooms full of kids' toys. There was a proliferation of kind of aspirational toys and a focus on this kind of individual creativity as a value. But toys are also, of course, a site where parents kind of inscribe their hopes on their children. And of course, children take up particular toys to explore the world, to try to make sense of things that maybe don't quite make sense to them. But when it comes to marketing toys, there is definitely a lot of like adult projection and hopeful anticipation of, well, this toy will help my child become an X.
Yeah.
Will become a doctor, become a programmer, become whatever it might be, right? And that history, going back long before computer games, is so gendered. It continues to be, sadly. And again, individual kids will break through those molds, but they really have to push back against a lot of cultural messaging that encourages some kids in certain fields and discourages other kids.
Yeah, my own history with learning how to program was, I did have people who my parents who had a PC in the home, and I found some books and materials, but mostly nobody ever really pushed back or told me that, like, oh, I didn't think you would be into programming, or even those subtle little cues that discourage people from pursuing some lines and encouraging other people. We pretend and tell ourselves that, oh, we're not so easily persuaded by these tiny little things, but it actually does have a large effect that you can see across a population.
Absolutely. And moreover, those little comments can accumulate, right? They plant a seed of doubt in a child's mind. And then maybe they hear another version of that message, and that grows that seed a little bit. Maybe they hear something a little more pointed, somebody kind of maybe just telling a joke, but making fun of kids who have that interest, kids like them who have that interest. And that continues to grow that seed, right? So certainly there are times when there is explicit gatekeeping, there's explicit exclusions, but often there are more kind of implicit messaging. There might be, somebody who's not welcome at a particular club. And sadly, I even saw this happen in Paraguay when I was doing field work on One Laptop Per Child. There was a hackers club that one of the volunteers who was down there, who had previously worked for One Laptop Per Child, but was working for Paraguay Educa at the time. He ran a great kind of coding club on Saturdays. He really wanted all sorts of kids to come, but it was all boys that came. And there was one really precocious girl who I thought would be great there. And so I talked to her mom, who was really a booster for the project, really understood it in a way that many there didn't necessarily. I said, why isn't your daughter going to this club? She'd be great. And her mom said, it's all boys. It is not a safe place for her. Even though her brother was there, I don't want her being the only girl in that space. And I thought, she has a point. I mean, Paraguay is, rooms full of boys may not be a safe place for girls along multiple dimensions. And I kind of don't blame her for saving her daughter from that experience. But it broke my heart at the same time, right? And these kinds of things play out all over the world. One thing that I really love that's pushing back against this, and in fact, I hear this as an entry point for so many girls today, are girls' robotics clubs. These often start usually in high school, sometimes in junior high. They often operate kind of alongside co-ed robotics clubs, but they make a safe place for girls to be able to explore these ideas, to not feel like they have to be one of the few or maybe the only girl in the room, and to be able to find camaraderie with other girls who have similar interests. So I find that really, really promising as a new direction, new way that people are getting into it.
We talked about sort of historically entry points for programming. I thought we could talk about a little bit, just kind of wrapping up, what are potentially other possible entry points for programming. You mentioned that robotics and the girls' clubs for robotics, which I think is fantastic. And I did a little survey online on Twitter just to kind of get an idea of, my small audience. And I tried to have people retweet to get kind of a little bit of a reach. And definitely the older crowd, it was, they were all models of what you have in the book of like, precocious boys, everything from VIC-20s to Spectrums, if they're like from England or what have you. These other kind of early computers were, brought into the home, and the kid was, allowed to kind of play with them and kind of grew up with them and being in that. But what I see from the younger audience that I have is various, very different entry points. And there are, one mentioned Minecraft. I thought this really fun one was that they were playing a game called Club Penguin.
Oh, a Club Penguin. I remember that.
And they wanted to automate it and basically figure out a way to do that. And that was their entry to programming. Another one was, a lot of them they got into science in college and were frustrated to the point where they were like, I need to automate this experiments and other things, and turned to programming and kind of fell in love with it from there. And so I wonder about that. And you mentioned several times this idea of like, what it's kind of like the why of programming isn't really there for in the idea of, let's spend an hour of code. And it's like, well, why? Like what am I getting out of it? Well, you're learning how to code. And it's like, well, what can I do with that? And that was a problem that I had early on, because I dropped out of electrical engineering because I didn't find computers that interesting at the time. I got into a band, and I was, totally into the music kind of thing. And that's kind of where I kind of swam in sort of music technology. And now computers can kind of do all those things, but I feel like there aren't always explained the entry points into it. I mean, you mentioned a couple that I wasn't familiar with. The Tam thing sounds kind of interesting as a music entry. Video games have been one, and Al's written several books about, trying to get people interested in programming through creating games. Do you have other ideas of like entry points that maybe are kind of outside there?
Yeah. A friend of mine, Christo Sims, wrote really a wonderful book about this. It's actually focused on a kind of tech-heavy charter school that was started in New York, and its original mission was to really foster entry points for underrepresented students of various sorts, right? They had a big Latine population, a lot of girls. One thing that he found in his ethnography of this school, a lot of kids loved music remixing and, coming up with clever memes sometimes, right? The TikTok cultures. I feel like there is a lot of richness that happens in these spaces that is underappreciated as a kind of technical entry point. He was at the time under the umbrella of connected learning. It's this movement headed up by Mimi Ito and others that really tries to use children's existing interests and existing kind of communities and friends and cultures as entry points to scaffold into learning of a lot of different sorts. It doesn't have to be programming, but I think music mixing definitely lends itself to a certain kind of computational thinking. Sadly, what Christo found at this school, though, was that those kinds of technical expressions were almost systematically undervalued by teachers. The teachers who were very well-meaning, right? They were working at this progressive school. They really wanted to support these kids, but they would say, no, that's not the idea I have for what a technical kind of activity is. What you need to do is program a video game or program something else, right? There's a kind of focus on that. And I think it's important to have those entry points, but it's also important to have entry points that really start and are grounded in the cultures that diverse children exist within. Yeah. And to take those cultures that children exist in really seriously as starting points. That's one thing I love about cultural studies, which is, I would say, one pretty strong influence on my own scholarship, right? It takes popular culture, including children's cultures, really seriously. It doesn't discount it as kind of frivolous or just mere entertainment. These things have real influence on people's lives and on people's worldviews. And so that is sadly a kind of sad tale, but I think there's a lot of potential there, right? In kind of scaffolding up from TikTok culture, whatever it might be, from music remixing into computation. And I feel like there too, there is a wonderful opportunity for really addressing some of the more critical angles, right? Of quality control, of kind of community building, of maybe using kind of restorative justice models when things kind of go south, right? So I kind of love movements towards that I see. I mentioned girls robotics clubs also. I've heard from so many how crucial that is for girls in particular. I also look to organizations like Black Girls Code, and their mission is a little more directly about coding, right? They talk about the value of learning to code. They don't necessarily have that critical angle, but they really do it from a point that starts with the culture of Black teenage girls. And I love that. I love the fact that they are run by largely Black women, that they know those worlds, and they really use that as a starting point.
I wonder sometimes if like the answer sometimes might be the idea of like, would you like more power? And I mean that by like, over your life, over, the jobs that you're doing, giving yourself more time, controlling all these devices that are around you, or, like you said, the idea of like this critical perspective on like how technology is being used against you. Well, could you turn the tables a little bit in the sense that, how are you being tracked? And, the idea of like using this technology in a way that empowers you more as opposed to necessarily being a consumer, which isn't terrible, but there's so much more to it. I also think about the idea of people trying to push STEAM back to STEM.
Yes.
Taking the art out of it, and which I kind of is really interesting to me, because like, to me, everything that's interesting about computers is the artistic side.
Absolutely. Well, I'm so glad you bring up power too. And I think this comes back to what we started with today, right? My own motivation for studying computer science back in the day. When I came to Berkeley initially, I was going to be, I think, an English and an astrophysics major, because I didn't know what the heck I wanted to do. And I figured that would like hedge my bets. I could do a lot of things. There you go. But I was quickly drawn to programming because it felt powerful. And the way it was talked about in my classes was powerful. It was clear. I mean, there's an economic side, which I understand as a kind of necessity, but I find limiting, right? The like, oh, there's a good paying job at the end. Like, yes, right. Being able to pay the bills is important, right? Nobody should starve for their ideals, even though sadly people are in those positions all the time. I would love the humanities and social sciences to be a lot better funded, but yes, but we're in a kind of, market-driven neoliberal kind of economy.
We have so many apps to create that will save the world and make it a better place.
So yeah, I find it a little frustrating that like, oh, it makes economic sense. But at the same time, I'm like, I understand when people are like, I hear from Latina students in particular all the time, like, I'm studying computer science because I want to make enough money to support my family. They came here, they've been, maybe there are a number of students at Berkeley who have like, their families have been working in the farm fields of Salinas or right. the Central Valley in California all their lives to support them. And they said, it's my turn to support them. That's why I'm studying computer science. And I say, go for it, right? But more broadly, I feel like that focus on the economic angle, which I hear especially from privileged white parents, right? I live in Silicon Valley. I'm surrounded by upper middle class families who are thinking carefully. You
got several projects you're kind of focusing on that stuff too, which is I think is fascinating.
Yeah.
A whole other episode.
The kinds I'd love to if you want to. It's I might need to get a little deeper into that next project, but the kinds of messaging that upper middle class parents who work in tech give their kids is really not tech critical in any way. It's very kind of instrumentalist and like, yes, you should study this because you can get a good paying job like me, right? And I have all the support that you need to scaffold you into this and to foster your interests here. the tech industry ends up just kind of recreating itself, right? Both through those means and also through the focus on these kinds of older, I would say, I would love them for them to be outdated. They are not quite yet, right? This
right.
social imaginary, the technically precocious boy, when really there's so many entry points into coding today. But we still tell that story. We still tell it through movies and through books and through news articles.
It's sort of what Facebook is also doing right now with Metaverse stuff, and really this is just from the novel Snow Crash from 1992, but now Facebook and Mark Zuckerberg have a lot of power, so they decide, hey, a VR and Metaverse, that sounds cool, let's create that. But it's really sort of a limited imagination of just their own nostalgia for things that were popular 20 years ago.
Oh, yes. And the Metaverse, like, that was a dystopian world.
It is totally dystopia. Every mention I can think of it, you know? It's so crazy.
But yeah, I mean, I think, you know, William Gibson and Neuromancer, I think, defined so much of the cyber libertarianism of the 1990s, right? The console cowboys, this idea of manifest destiny, all of the kind of colonialist connotations of that of course were kind of unquestioned by many then, but we can look at with a little bit more critical eye now. But yeah, we are still playing over some of those same kinds of, whether utopian or dystopian kind of literary worlds, whether it's Snow Crash. Man, I heard so much reference to Diamond Age in my research on One Laptop Per Child. Again, a kind of dystopian world. But they talked about the Young Ladies Illustrated Primer being a kind of motivator or model in some ways for what they were trying to make.
The Diamond Age is also a novel by Neil Stephenson, who wrote Snow Crash. And I know we're at the end of this episode. I could just keep talking for hours and hours, but I also personally knew Alex Peake, who was behind the Code Hero Kickstarter project. This was one of the first Kickstarters that hit the six-figure realm in how much money it raised, $170,000. And it wasn't necessarily a scam, although there were a lot of questionable things, and nobody knows where that money went. But it was this idea of, we're going to create a video game that teaches kids how to code, and they raised a lot of money for it, and it went absolutely nowhere because Alex was very much enamored with the idea of the Diamond Age and this idea of having this software that could teach. He said, not just coding, but he wanted his project to eventually be used to teach anything, which kind of dives into that whole idea with MOOCs and online classrooms that were also really popular a decade ago.
Yeah. In so many ways, the Code Hero story is almost a perfect recapitulation of many of the stories that were told about One Laptop Per Child, right? Kids would fall in love with this. They teach themselves everything. Of course, OLPC didn't have a 3D world. This machine was so underpowered, it could barely limp along with like playing an episode of anime.
It was like a 1 gigabyte hard drive and 256 megabytes of memory, which even back in 2005 was pretty
nothing.
Sparse.
Yeah, it was.
But it's enough to make text-based games in BASIC. So it should be enough
Why
for kids today.
Why would you need more?
Right?
Exactly.
Yeah.
Get that turtle moving.
So Code. I'm glad you mentioned Code Hero, just because it's again such a wonderful kind of or terrible if you.
Yeah, it was pretty awful.
Depending on how you look at it, re-encapsulation of so many of the same ideas. And one hope I have for all of this work is that even just reading this history of One Laptop Per Child and reflecting a little bit on it helps people recognize when these same stories come up again, whether it's in Code Hero, whether it's in maker spaces, whether it's, in the next new kind of ed tech project. Certainly VR, I think some of those same stories get retold. So my hope is that in recognizing those stories, we're able to kind of maybe resist falling into that charismatic trap. Yeah. I recognize that charisma in a way is important for getting funding for a project, for galvanizing support for a project, but I do feel like falling into that utopian vision really separates you from the lived experiences of people on the ground with diverse needs and desires and daily lives. And that is often what is missing in these kinds of projects, that good grounding. And honestly, a little bit of humility from the parts of developers, admitting that their solution might not work, that they don't know everything, that they really need to listen and to kind of put themselves in the background as much as possible.
It's quite the scarcity of humility out there right now.
I'll create the humility app, and we'll solve that problem.
Perfect.
A daily dose of it. Yeah. Well, I don't know how much time we have, but I at least would like to give you a chance to do any shout outs or sort of social connection information that you'd like to share.
Yeah, sure. If I were to do shout outs to people who have helped me along the way of all of these projects, I feel like we'd be here another hour at least. I think I've mentioned some along the way. There's some wonderful other literature. One that I haven't mentioned that I feel like has just been really inspiring for me as well is a lot of Lily Irani's work. She's a professor at UC San Diego and wrote this great book, Chasing Innovation, where she kind of breaks down this idealism around design thinking.
Oh, cool.
But she's doing a lot of great activist work now around like the San Diego Streetlight Project, which put these surveillance streetlights all over San Diego without really much oversight at all. And a lot of other areas, right? Kind of she helped kind of write Turkopticon and kind of continues to help run that world, that way of workers organizing, Mechanical Turkers organizing and pushing back against exploitative practices. Gosh, there's so many people. So I retweet many of these kinds of people. So okay. I encourage people if they want to connect with others, feel free to follow me.
Yeah, I'll include all that information. Yeah,
and I tend to be pretty leftist in my Twitter presence at least, but I do try to retweet a lot of useful things along these lines.
Cool. And Al, do you have any thing you want to shout out here briefly?
Mostly, I just wanted to just shout out the Charisma Machine because it's such an incredible book and such a relevant book for me because I want to teach people to code, and also I see, I lived in the Bay Area, the San Francisco Bay Area and Silicon Valley for about 12 years, and there are a lot of naked emperors out there, and so I felt like reading this book and just reading the ideas that were in it is just so important to avoid the next hype cycle. So I really want to shout out that book. And then also I write my own books, teaching people how to program in Python, and you can read them for free online. They're available under a Creative Commons license at inventwithpython.com.
All right. Well, thanks again, Morgan, for coming on the show. And thanks again, Al, for returning and bringing this to my attention. This has been fantastic.
Thank you both for this opportunity. It's great to get a chance to talk with you.
Thank you. Yes.
Don't forget, you can get simple cloud data connectivity to SaaS, big data, and NoSQL from Pandas, SQL Alchemy, Dash, and Pedal. Learn more at CData.com. I want to thank Morgan Ames and Al Sweigart for coming on the show. And I want to thank you for listening to the Real Python Podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python Podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and look forward to talking to you soon.